And welcome back, ladies and gentlemen, boys and girls, angels and demons, monsters and serpents, and pyramidians, to Brothers of the Serpent podcast, coming to you not live from the 10 by 10 by 10 tangent cube of science, nestled amongst the dusty bones of an ancient seabed high atop the Edwards Plateau. We got a full house today. We got GMA in studio. Hey,
buddy.
And as always, my co-host Kyle.
How's it going?
Yeah, and we got a very special show today. We had Christopher Dunn on with Robert Vawter and Eric Wilson. The three of them have been working together more recently on the Giza power plant and other interesting lost technologies of ancient Egypt. So we have, as all of you know, we have been going through Christopher's excellent books for the past couple of months. We've been doing a deep dive into lost technologies of ancient Egypt and more recently the Giza power plant. And so we were able to get Chris on with his two colleagues to talk to them about what has been going on since the writings of those books and the more recent research. And I think we just want to get straight into that. No space weather news and no story readings and no emails from anybody. We're just going to go straight into the interview. So,
Yep. It was fantastic.
It was an excellent interview, yeah.
Hope you all enjoy it.
Yeah.
Oh, yeah?
Yeah, Jimmy?
I'm ready.
All right, let's go.
Bumper music cued.
Ladies and gentlemen, we have a very special show for you guys today. We have Christopher Dunn with us here. He has an extensive background as a craftsman. He started his career as an indentured apprentice in his hometown of Manchester, England. He was recruited by an aerospace manufacturing company and immigrated to the United States in 1969. For the past 50 years, Chris has worked at every level of high-tech manufacturing, from machinist, toolmaker, programmer, and operator of high-power industrial lasers. He's been a project engineer and laser operations manager, and for the past 16 years, he has served as human resources director for a Midwest aerospace manufacturer. Christopher Dunn, thank you for joining us.
How's it going, buddy?
Great to be here. Great to be here. Thank you. Thank you for inviting me.
Yeah, we have been looking forward to this. We've been, as all of our listeners know, we've been going through both of your books extensively on our show for the past couple of months, and it's been a blast and has been mind-opening. We really love the history of exploration that you put in your books. Of course, your theories and ideas are also excellent, but the history of exploration in the beginning of each book that sort of lays the groundwork for how you look at these ancient structures, ancient artifacts, and everything has been fantastic. So we're really excited to have you here with us to talk about this stuff today.
Oh, thanks a lot. And I've been listening to your podcasts, and I've enjoyed them immensely. You are probably the only radio hosts that have done such a thorough job of examining the material. Normally, somebody will ask me to come on a podcast, and I have to guide them through the material because a lot of times they haven't really examined it. But so I'm really delighted. Was really delighted to find your podcast. It was most excellent and a lot of fun.
Thank you.
Yeah, it's been, and so I wanted to say we have our friend Archer, who is also an engineer. He's here with us in studio. Archer actually introduced us to your newest book, the
Technologies of Ancient Egypt.
Lost Technologies of Ancient Egypt. He was the first one that was bringing the material in, and then that made us, I was like, I got to get this book. Archer actually loaned it to me, then I ended up buying it, and then we went through it in depth on the show. So we have him here with us because he's an engineer, and he's also very much enjoyed your take on on all the artifacts, right?
Oh, absolutely.
Yeah. So.
Oh, hi, Archer. Nice. Thank you very much for recommending my book.
Oh, thank you.
And could I introduce a couple of friends of mine?
Absolutely.
Russ and Kyle? I have with me Robert Vawter, who is a sound engineer, and Eric Wilson, who is a engineer with Rolls Royce in Indianapolis.
All right. Well, hello, guys.
Thank you, Chris. Yes.
And so perhaps, Robert, you can give your bio, and then Eric, so everybody knows who they're listening to.
Yeah.
Okay. Well, real quickly, I've had kind of two careers. My first career, I was a front of house sound engineer. You go to the concert, there's the guy out there with all the knobs controlling the sound. I did that for off and on for 20 years, blew my leg out and had to find another line of work. The only other thing I was really interested in was ancient civilizations. So I went back to school and worked on an undergraduate degree in anthropology and archaeology, and then took my postgraduate work in ancient medieval philosophy. Ended up in and out of Egypt for the last 22 years.
Wow.
And I've known Chris for quite a while here, and we've been exchanging ideas. So I end up here on the podcast with you guys.
All right.
Excellent.
Eric, my friend.
Yes. Okay. My name's Eric Wilson, and as Chris said, I work for Rolls Royce Corporation, but they're not affiliated with this research. They do enjoy it, but not directly. Right now, I'm a technology researcher. I work in the control systems department and do thermal management for electronics. I have a master's degree from Purdue University. Before going into engineering, I took aviation maintenance, and my engineering degrees were in electrical engineering and mechanical engineering. So I met Chris only in 2017, and before then I had really no interest in archaeology or these ancient sites, but I reviewed some of the things that he had put on YouTube, and it made sense. And then I looked at the back of the book and realized he lived an hour and a half away from me. So I gave him a call, and we met, and we've been going since then.
All right.
Around August 2017.
Well, I think that's kind of what happened to Archer, except that they're a little farther apart. But he was like this, as he was reading the book, he was like, guys, this is how you look at this stuff. And I agree so much that like it takes an engineer's eye to see previous engineers' work and to recognize it for what it is, right, Chris? That's a big part of what you're talking about in your books.
Yes, I mean, it is. That's exactly it. Because if you look at it, I mean, I don't mean to be an elitist or critical, but if we were going to build a similar device or structure, we probably wouldn't consult with Egyptologists to do it. We would bring engineers, architects, and all kinds of different crafts and skills to accomplish the work.
That's a good point.
Yeah, it is a good point.
I definitely wouldn't ask an Egyptologist.
Maybe that is elitist and critical. Oh, well.
But I mean, look, if you don't want to be building it with copper chisels and stone hammers and butt flaps, then definitely don't ask the Egyptologist.
Yeah, that's right.
The interesting thing, just a little backstory, I've been researching this since 1977 and actually debating it online since 1995 in the early days of the internet when they were using these bulletin boards, and one was called Deja News. And on one of the debates about core number 7 in the Petra Museum, one of my detractors was saying, "Well, I'm just a lone voice in the wilderness. Nobody's listening to me." And it seems like now here we are, 25 years later, and the number of engineers and technicians that are now traveling to Egypt and recognizing all the things that I pointed out over the years. I mean, the numbers are huge. Yes. So it's turning. I mean, I think that particularly in Egypt, the mindset is turning towards recognizing that their ancestors were a lot more advanced than what has been discussed in academic literature in the past. So that's a good thing.
It is a good thing. And we're trying to help that with the podcast. We're trying to because Kyle and we're not engineers, but we are builders. We have been building things our entire lives. Our father was a builder, is a builder.
Yeah.
And so we recognize, at least from the building aspect, when you're looking at it in terms of like constructing something, we see like, okay, this doesn't make sense with their explanations. Now, you point out multiple times in your books, and I agree with this, that there are many ways of doing something. And
Right.
so that just because somebody has demonstrated that something can be done one way does not mean that that's the way it was done.
Right.
And it requires looking more at the evidence on the site to try to figure out how they did it, instead of saying just because we have proven that it can be done this way that's how they did it. And I completely agree with that. So,
Well, yes, I mean, and even today, human nature being what it is, if you have a group of guys and they get a project to do, they complete it and do it a certain way, and then that project is given to another group, that other group will do their darndest to find a different way or a better way of doing it, and not actually mirror what the other group had performed.
that's right.
So, it's like professional pride. Oh, they did it this way. Let's see if we can do it better. A competition, ego, you name it. But it exists, and I've witnessed it over the years. And so that's why I say, I don't hold firm to any particular method, as long as that method will explain the evidence. And it's the evidence that is driving the bus right now. You can't come up with some crazy idea and it doesn't satisfy the evidence.
Right. That's absolutely right. So let's get more into. Kyle and I have pretty thoroughly covered your books, and so we can talk about some of that if you want. But I also want to know like what's happened since the writings of the books. What has developed since then? What have you determined since then? Like I know that you've been looking at the ScanPyramid stuff. That's pretty new. So
yes, that's quite a story in itself. And my two research associates, Robert and Eric, everything came together at a confluence when Robert and I were riding in my car, and we were talking about that. And a call comes in from Eric, and he's all excited because he'd accessed the ScanPyramid information. And Eric, I'll let you take it from there.
Yeah, this is sort of when we first met, and I had just started studying and looking at the pyramid as a circuit, right? And to see regarding the microwave energy that would excite the King's chamber, what holes there may be in that, and Chris he set an amazing foundation, but just before I even knew about ScanPyramids and what they were doing, I had contacted Chris. We met in August, and then I contacted him around October and said, "Hey, I've reviewed a lot of things here, and I think the southern shaft needs to have an amplifier for it to work. If it's the input to the King's chamber."
That would be the northern shaft, right, Eric?
Yeah, I'm sorry. Well, even me, I get them confused. I'm not that deep into it.
no problem.
Yeah, so I need an amplifier for it to work, and that's Chris. At that time, it's just a few months of knowing each other, and I a little bit ignored what I was saying, and then lo and behold, a month later, the ScanPyramids group, who I've never heard of, says, "We've found a void," and they're saying it's exactly where I said I need an amplifier for your system.
Oh man!
And then I got a hold of Chris and said, "Hey, this void, it aligns with the shafts where I said there needs to be an amplifier. What's going on?" And,
stop ignoring me, guy.
it kind of sparked like, whoa, we need to start paying attention. I'm telling Chris, your phone's going to start ringing again. People are going to start asking, what's the take?
Yeah.
And what can I do to help? And so it kind of went from there. But But just our last trip, March 2019, by chance, not organized or anything, I happened to get a whole day in the pyramid with the ScanPyramids group, the group from France. And you might like the way that worked out. I tried to go to Red Hot Chili Peppers concert that they were having, that was happening at the pyramid. That was a once in a lifetime event.
Wow.
Barely made it in time for the ending, like 2 songs. And Ahmed El Gandhi, who handles he's a director that handled the projects. He was bummed out. He said, "Hey, come to work with me tomorrow. It'd be Saturday. Just spend the day so we at least have some time before you leave." And the ScanPyramids group was there. And I'm not working with them, but was able to meet them and witness what they were doing and get some insight. And they were working in March to replace the scan plates and do a sharper, I guess, or more focused scan of the void they had found the previous year. And all I know now is they've got data, but they're going to do another scan. All of their work's been verified by another team from Japan. Right. And they're going to do a verification, and then in the fall of this year, they're supposed to release a combined official, verified statement of what this chamber really is, at least from a scan perspective. So.
Wow. So are they using the muon detection plus? Do they have other detection methods like?
From what I know, they continued with the muon detection. They had improved their equipment from the previous year, from the 2018 scans. And they were just trying to get more precise on an area they believed to, this large void.
Yeah.
It's muon detection. What I've read, and this is just from article, this is not for the Japanese group. There's an article that says they're supposed to project actually some more intense muons on the location to see if they can get a better image on their scan and compare the data.
Excellent.
So
That's
I
really
speculate.
exciting.
It's no evidence. The only evidence I have is that if this is a circuit, it needs an amplifier. I speculate in that location we would want some type of crystal microwave amplifier. And it could be simply crystals. They'd be very large, I think, for the amount of energy we're dealing with, to excite the microwave signal into the king's chamber.
Man, that would be amazing if that was what was in there.
But if they find it, your amplifier is going to be called the Iron Throne of Khufu, right?
Yeah, I mean, who knows what's in there? But it's not, as far as we know, it's not been disturbed. It's a chamber that's not been robbed, and undisturbed for many thousands of years.
Yeah. So no matter what's in there, it's going to be game-changing and phenomenal because it has it.
Yeah, it's going to open eyes.
That's right.
For sure.
If they tell us what's in there.
If they tell us, right. That was the other thing is that the Antiquities Department seemed to get very upset with the ScanPyramids people the last time they released information to the public. So that was interesting. They got pretty mad that they claimed that they jumped the gun or something.
Yeah, I agree with them because they were supposed to maintain protocol.
Okay.
But I don't think anyone's hiding information.
All right.
I do really believe that the generation that's there now is waking up and realizing, well, this is different. This is not what we thought, and they're willing to bring this stuff forward.
Okay.
They're trying to maintain a government type protocol and everything.
That's very reassuring to hear because the previous regime was not like that. So I'm glad that it's seeming to change then.
Right.
The previous regime is still there, but they are being encouraged to open their eyes a little more.
Oh, okay.
I can't say that that's working all the time, but
as Chris said before, it's opening the eyes of a different group coming to Egypt. Not so all esoteric people, but engineers that see systems within,
Right.
that see what Chris has discovered in machining, and realize that this thing had a specific purpose, not just a tomb.
Right. And not just that, but there seems to be evidence of massive machining projects all over the place, aside from the pyramid, too.
oh yeah, absolutely,
Yeah.
absolutely.
including the pre-dynastic materials.
Yes. That's right. It's this goes back a long way, and it's hard to tell. You know, we do a podcast with Randall Carlson, so we talk a lot about in that one we talk a lot about the end of the Younger Dryas period, which was very destructive, caused an extinction of megafauna, caused bottlenecks in human population. And Chris, you don't say any of this in your book, so I'm not trying to ascribe any of this to you, but Kyle and I have thought a lot about how it's very possible that there may have been a previous more advanced civilization. What you would think of it as advanced, like a maritime civilization, a long time ago, deep in prehistory. You know, like Göbekli Tepe points to this kind of idea. So,
Yes, I mean, I do kind of hint at that.
Yes.
I kind of limited the scope of my work to how it was done, how the pyramids were built, and what they were built for, without much regard to the who and the time frame.
Right.
You know, because that's I leave that kind of work to historians and futurists to stay within my lane, so to speak, and the engineering. It is less ambiguous. I mean, it's very difficult to argue with the hard evidence. You can interpret it a different way, but the evidence speaks the loudest, and it's unambiguous, in my opinion.
that's true, and I agree with your take on, or with your with the way you've chosen to do it, with staying in your lane and here's what we see, and you're not really saying who or when. I think that's
right.
That's a powerful way to do it, because you're right. It's all about the evidence, and this evidence doesn't necessarily tell us who or when. It just, we're looking at how and why. So,
yeah, I mean, there's a lot of discussion about, well, what happened to the machines? You know, where are the machines?
yes,
Because it's obvious that the tools that we used are not in the ancient Egyptian toolbox. And so that leaves a huge question mark on that subject.
that's right.
But it doesn't mean that the machines obviously existed, because you can see the marks that they made. But the question of where they went to, that's a totally different subject.
That's right. And machines, if they're made of metals, they may not survive very long. Metals don't. It's hard to preserve them sometimes. They corrode easily. So we've talked a lot about that too. That if you've got a bunch of machines made of metal, they're not going to stick around as long as something made of stone. So
yeah. Well, I mean, to your point that a advanced civilization existed in prehistory, I think that's self-evident. I mean, it's obvious to me that they had to have existed in order to create the products that we see there now.
absolutely.
Yeah, I was going to talk about that a little bit, on the idea that there are multiple ways to do things. Archer gave us a presentation on the podcast about precision.
Precision. Yeah.
And, it's an interesting rabbit hole to go down, because when you're trying to figure out, well, how do you get flatness to begin with?
Yeah.
Well, how do you, first, because you start off with, you have these measuring tools that you can measure flatness, and we were trying to figure out, well, how do we know that those measuring tools are flat?
Yeah.
And so he kind of led us down that rabbit hole, and Is there more than one way to get flatness, or did they have to basically rub 3 slabs of stone together until they arrived at that? And then if they did, where are those stones? Where are their surface plates?
Yeah, that's the precision on flat surfaces. I mean, that's kind of two-dimensional stuff, and a lot that's easier to understand. And we know that in history they were creating flat surfaces when they developed the printing industry. So that was a part. I think as far as precision flat surfaces, I don't think they existed before the printing industry. I mean, the precision and accuracy of optical lenses is well known, but that is not, those are not necessarily flat surfaces. And then you move to the Industrial Revolution, where flat surfaces were necessary for machine tools. And not just for the machines, but also the surfaces that you had as references to measure the distances and accuracy of the parts that you were making.
Right. So
that's our history of flat surfaces, and so if you go back to the Industrial Revolution to find something that you can compare with some of the artifacts that you find in Egypt, then you're bringing the capabilities of the ancient Egyptians forward thousands of years compared to what they have been credited with in the past.
Right. Yeah, that is pretty astonishing.
Right. So I guess I didn't actually get to asking the question, but is there more than one way to arrive at a flat two-dimensional surface?
Well, you do have the 3-plate method that is well known. There is comparative measurements where you use a surface that is known to be flat, like a gauge or something like that. And then there are ways to remove material by comparing. You use a die on a surface and rub a plate over it, a precise plate, and it will reveal high spots. And so you essentially just scrape away at the high spots until you have a flat surface. And then, with modern machines, you can create fairly flat surfaces to within a half thousandths with a milling machine. And if you want to go closer, like to 10,000ths or 1/10,000th of an inch, then you go to precise grinding equipment. And then, of course, the finishes. You if you wanted a very, very fine finish, a lot of times you would go to lapping the surface. But there's so there are different methods.
But these methods
to apply, but it depends how flat you want your surface.
Okay, and a lot of those methods that you mentioned require previous flat surfaces, like in order to have a milling machine in the first place.
I mean, that's your that is your datum. I mean, the ways on the machine are essentially control the precision on the artifact that you're creating, or the workpiece. And if you don't have an accurate machine, then you're not going to have an accurate workpiece. And that's what the development of technology has been for since the Industrial Revolution, is actually working out the variables in the manufacturing process. So the machines today are much more precise than they were 50 years ago.
Right.
A lot of secondary operations had to be performed 50 years ago, such as, you have skilled fitters who would actually scrape bearing ways or bearing surfaces and stuff like that, because the machines couldn't get the surface finish or the accuracy on them.
So one question I have for you is, if you were to try to give a general idea based on the evidence you saw in the artifacts, in the buildings, in the structures, where would you place the people that made those artifacts and structures in terms of what we think of in terms of modern technology? Like, what time period would you place them in general? Like during the Industrial Revolution, or would it be more recent?
I think it would be more recent. I mean, I could torture myself and try to imagine creating a Ramses statue with tool and die making equipment 50 years ago, but it would be torture to try and accomplish that.
Especially to do it 4 or 5 times and have it be exact, right?
Right.
Yeah.
I mean, you've got precision, and you've got symmetry, and you've got geometry, and it's all these elements working together: 3-dimensional geometry, 3-dimensional surfaces that are extremely precise. And you know, when back in the old days, when we used to make dies and stuff like that, they would profile them. They would create a wooden model of what they wanted, which are not necessarily ultra precise in themselves, and then they would put them on a machine that would follow the model with a stylus that moved the axes on the machine to allow the cutting of a metal object. So say you were trying to create a car body or something like that. That's how you would do it. You would create a mold. But these machines were called Keller machines. They were electrical impulse kind of movement on them. There were other machines that used hydraulics. But essentially, if you go back and you compare a car that was made in 1974 and the fit and finish on those cars, and compare them to a car that was manufactured last week, you would find a remarkable difference. And it's not just the development of machine tools and the accuracy, it's the controls as well. CAD/CAM, stuff like that. I mean, it's a huge leap to say, okay, yeah, the ancient Egyptians had CAD/CAM. Oh,
right.
Get out of here. Come on, you got to be kidding. No, well, you know, look at the product and then say, okay, what is the minimum? What is the minimum that you would need to create this thing? And a lot of people have actually proposed, well, you know, you can mirror something by taking a piece of string, and then as soon as I hear string, that's when I shut down. I'm like, okay, I can't continue this conversation if he's talking about a piece of string achieving that kind of accuracy.
Right.
You know what I mean?
Yes, we completely.
It doesn't work.
We completely agree. Those little diagrams they have of the guy holding the string to get the perfect corners or whatever on the flat. I'm just like, no.
Maybe if they said chain, you'd stick around for a few more sentences.
Oh boy. Yeah. So I choked on my coffee on that
one. Yeah, you got to be careful drinking coffee around Kyle. He's cracking jokes.
Yeah. All right. Sorry about that.
No problem. That's the idea that they. I mean, I guess I'm thinking of your thought process on that it seems more likely that they were able to do this with CAD than actually like the stylus type mirroring or machining. As far as the Ramses statues are concerned, that is quite a leap, like in technology or in technological advancements. So
yeah,
but it seems like
engineers, they let their imaginations soar.
Yes.
Archaeologists and Egyptologists would rather we didn't do that with ancient artifacts, but you know, that's our nature.
Yeah, but I mean, still this still goes back to the idea that there's more than one way of doing it. So yes, there are these other ways that you know of that we went through these processes throughout the Industrial Revolution and since then, but they would be tortuous, as you said, to try to achieve the things that you see there in Egypt. So it's more like what you're saying is that it seems more likely that it was easier for them. They were using more modern technologies.
Yeah.
yeah, without the benefit of modern technology, machines and methods, it would be. I don't know if it could be done. And the thing is, I try to be fairly conservative in what I would argue for. Some of my colleagues, engineers, think I'm too conservative, and I should be more forceful in arguing for CNC machines, for instance. Mm-hmm. So, that's some people. It seems to be too obvious to them. I being the front guy on this, I've already taken enough slings and arrows.
Yeah.
And I try to be a little more careful and conservative.
Yeah. Okay. Well, you did bring up this idea in your book that, and it wasn't a theory or anything. It was just sort of conjecture that if, for example, the Egyptians had, say, solved some of the problems of dealing with gravity, then they wouldn't need the wheel, first of all.
Yeah, you'd be freed from the wheel.
Right, but that would also make the machining of massive pieces of stone much easier. If you could move that stone around instead of the machine tool, or even that the machine tool, you didn't have to worry about gravity so much with this massive machine that was going to be cutting on the stone, or vice versa.
I don't know. The way technology is being developed now, if you're looking at the way drones actually work,
yes.
Is it possible that there may be some time in the future where within a holographic or a matrix, you have a piece of stone and then a drone that has a ultrasonic cutting tool that is actually cutting away, being guided by some kind of very, very precise GPS system.
Yeah,
That sounds ridiculous, doesn't it? But think about it.
Not really. I've got a very high-tech drone. It's one of the brand newer ones, and they've already got software that I have. I haven't tried it yet, but you can program extremely precise pathways and the drone uses GPS and other sensors and everything, and then it will fly. Like, you don't have to control it. You can program the pathway in 3 dimensions. And then the drone will fly it precisely where you can basically maneuver it between very narrow things, in between trees, and it has automatic obstacle avoidance. So, no, I think that you're right. You put a few more instruments on that drone, and it could do that for sure. You'd have battery power problems. That's our main issue with drones, is battery power. But
that's because they're using fans to create lift.
That's right.
Movement. But if you had some kind of anti-gravity technology that you could employ, it would you wouldn't need as much power. I suspect.
Yes.
You wouldn't need as much power.
Yeah, Chris, could I interject something here?
Sure. Go ahead, Rob.
Yeah. There is one rather obscure text that does speak about an anti-gravity technique to build the pyramids. It's a Coptic text called the Al-Masudi Scroll. You may have heard of it. It's in the Bodleian Library at Oxford.
Haven't heard of that one. Let's hear about it. Well, we're writing it down.
Basically, it describes building a road out of a strange material, and the priests would strike the road with their sticks, and the rocks would float.
Oh.
And they describe the priests being stationed about a bow shot away from each other, so that the image that comes to mind is some sort of a relay station that your charges are being put into this road and moving the rocks a certain amount of distance to keep them under control. You wouldn't want to put a big charge in and shoot it down the pathway and have the new guy on the block sitting there at the end saying, "I'll stop it. It's still got mass." So that's the only text that I know of that describes anything like that, but it does exist.
But but so you saying that reminds me that there are, I don't know if they're texts exactly, but there are plenty of legends, myths, oral traditions that talk about a lot of these ancient sites, Baalbek, Nan Madol in Oceania, these places being, built by people who use some sort of sound or whistling or trumpets or something like that, and the stones would float into place. There are. You're right. There are legends about that. So
yeah, I think the Tibetan monks supposedly they used the alpine horn.
Yeah,
alpine horns and drumming.
Yeah.
Yep. And then there's the Vimanika Shasta, the one that talks about, the Indian Vedic text that talks about flying machines. So
that would be the Mahabharata and inside the Upanishads where they're talking about Vimana, Indra's dart, and things like that.
Right. That's right. Some kind of mercury vortex, something. I don't know.
That's an interpretation of the text. The text doesn't use those words.
Right. Yeah. Right.
You have to be careful there.
Yeah, but we still want to spin mercury really fast.
Yes.
And we want to electrocute it.
How's that going for you, Eric?
We got drawings.
Okay. Wait, you're working on this?
Wait. Oh, man. Rolls Royce is gonna feed us to the
send me your spinning mercury videos now.
It's not, as I said, it's not directly affiliated with Rolls Royce, but it's a special group of engineers that discover these things and say, well, let's try it.
Yeah.
Where can we get as much mercury as we can find, which seems to be quite difficult.
It is.
Which raises a question: why is mercury so protected and like taken away?
Yes,
but it's poisonous.
I like the way you think, buddy.
yeah, it'll kill you. Didn't you know that?
Well, bleach will kill you, but you can buy it by the gallon for $3 a pop.
That's true.
Or you could build anti-gravity devices with it.
That's right.
The general public can't have that.
Yeah.
Well, I guess the government doesn't want too many Mad Hatters around. Because that's
right.
You remember Alice in Wonderland, the Mad Hatter?
Yeah.
Right?
Yep.
That's what they used to use in hat making was mercury.
Oh, that's why he was mad.
To give it the nap, or to give it the sheen. So
wear that hat too long, you go crazy.
And then the Hatters would. With enough mercury and alcohol inside them, they would do some nasty things.
Oh yeah.
We do have, like you said, we do have some drawings, and the idea was to induce a current into the mercury to get it to spin around a Tesla coil in the center.
Yes.
That's some of the designs we had found.
Man, loving every minute.
But we have real work to do, and we never quite get down to it.
Yeah.
Right.
Yeah, we know that feeling.
Well, you gotta get paid.
That's right.
Yeah, there is that.
Yep. You don't want to end up like Tesla.
Right. Living in hotel rooms. So I have bringing this back on track here. We had a question about the so in the power plant idea, we didn't quite understand this, Chris, and that is how does the face of the pyramid act as a sort of a satellite dish to focus? Can you explain that to us a little better? We didn't get it. We didn't quite get it.
Focusing the cosmic microwave background.
Yeah, into the north shaft. How does that work?
Yeah, I mean, there would have to be a secondary reflector if it's collected off the outside. And that's just like, what is the reason for the indentations on the faces,
yes,
the concave faces? And that was just a suggestion. I mean, it may not serve in that capacity. It may serve in another capacity, but it was just an idea.
Right.
I was just brainstorming. Evidently not very well in that case, because it's like, okay, how would that work? If you have like a satellite dish, you have a large collector, and then it focuses into a secondary horn collector, and the same thing for the Great Pyramid. in order to direct the microwaves down the northern shaft. So you collect it from a larger surface. Does that make sense?
That does make sense. So that's what I thought, that there would need to be. I couldn't quite get how it would work without something else there, but you're saying that maybe there was some other secondary part that helped collect it. That does make sense. And so I'm thinking now of I'm trying to remember, because Kyle and I did 2 episodes on Gantenbrink's explorations of the shafts.
Yeah.
And we basically went directly to his website where he just details everything, and we read most of it on the podcast. And there was one part, and he's talking about one of the King's Chamber shafts where they found the niches in the end, at the very end of the shaft, towards the outside part. And he was saying that wasn't on the other side, and I think that they found those in the north side. So that may imply that there was something, installed in the end of that shaft towards the outside of the pyramid, which is interesting.
Yeah. Well, I think Eric, you have something to say about that?
Yeah. There's also a curious feature in his data. If you look at the files that were created, it looked like he did it in AutoCAD.
Right.
2D side images of where they saw stone splits as they went up scanning with the robot. It turns out that we looked at that closer, and at the point in the northern shaft where this void has been found, there's a larger block and sort of an indentation it's an upper block in the shaft, and it's much longer than the others. And our debate with one another, speculating why would this stone be longer, matching up with this void that's found, that it may be a juncture for a wall or roof support for the new void they've found.
And that block has a protrusion on it, doesn't it, Eric?
Yeah, that's what I was trying to explain. It's difficult to explain without the picture or drawing it. It's got a bump into the chamber, like a restriction for some reason. Mm-hmm. And the only thing I could come up with is possibly it's eroded away, but if it is an amplifier section, it's a point where something metallic would interface with the shaft to get the signal amplification or receive, transmit. That's speculation.
There's, if I may, there's one other little detail about that north shaft that Eric and I have talked about quite a bit on the side, is that if you look at Gantenbrink's CAD drawings, you see that as it gets down towards the antechamber heading into the King's Chamber, it makes several rather awkward turns. In other words, they went through a lot of work to make sure that hole comes out in a specific place.
Yes.
In the King's Chamber.
On our last tour, the tour that Robert was with us, we were all together. One of the attendees for the tour was a microwave guide designer. He was retired, but he'd done that previously. And he said, yeah, you guys, we didn't anticipate this, but he said the shape that they take to make these curves matches what I believe I'd see to maintain a guide to keep the proper dimension.
That's awesome.
Yeah, that's really cool.
Yeah, and then also when you look at that side view, after it makes the S turn out of the King's Chamber, it does a shift in size. It steps. It's a smaller size coming out of the King's Chamber, and then after it makes its S curve, it does a step up in size of the shaft, and it's abrupt. And I looked that up in some microwave design guidelines, and if you want to do a longer transmission, you have to do the step up to stop an impedance loss, and it matches.
That's very interesting.
Yeah, that is very interesting.
I hope I explained that well. I don't have drawings, but
No, I mean that's
So would that indicate that
it
that's
floors you.
the
It's like,
output?
holy crap.
yeah. I mean that is the thing. It's like when something that significant is revealed, it's almost I'm speechless. It's because
There's more pieces. I mean, Robert and I sat. What's the hotel, Robert? We were at the German
The
hotel.
Steigenberger in Cairo.
We had nearly a day there just to relax, but we were going over details and we were curious. We got some drawings out and we discovered that the entry to the King's Chamber, if we're dealing with microwaves, if we're dealing with insertion of heat, energy into a space, we'd like to see that at a quarter wave distance from the walls. And it is exactly 1/4 of the distance into the chamber if you get it in and study that.
yeah, that was
Where am I?
that was pointed out to me by a physicist by the name of Dustin Carr many years ago. That the quarter wave is important for a thermoacoustic engine, and the location of those shafts is a quarter wave down the length of the King's Chamber, which that's another point
Yeah,
to make.
that's really so. Okay, so this is another question we had when going through the Giza power plant, and this is: do you think that it ever worked again after whatever happened inside there that broke, all that stuff in the chamber? Do you think they were able to repair it, or do you think it was decommissioned after that?
I don't think they repaired it.
Yeah. I mean,
But-
those beams that are going across the ceiling, right? If they broke all the way across, it just doesn't seem like it would work anymore after that.
Well, it certainly reduced the efficiency of it, but I don't know. I just don't know. I mean, there are so many, I think, red herrings.
Okay, all right.
It's just like I know in one of your podcasts you talked about the grapnel huck and the cedar wood and the round stone ball. And for me, as I look back, that was a red herring for me. And if I'd have thought about it longer, I probably wouldn't have included it in the book because it wasn't necessary. And it was probably, like you said, somebody, just trying to reach in there to see if they can retrieve something, pull something out of value. But it's one of the mysteries, right?
It is one of the mysteries.
How did it get there?
Yeah.
It's one of the mysteries, yeah.
Well, you find a hole in the side of something, you want to see how deep it is. The first thing you do is drop something down in it.
That's right. That's right. But they would have to have been finding the hole from the top.
From the top.
Yeah.
Yeah.
Which is also interesting. Yeah.
Which is another interesting rabbit hole we could go down, but it's kind of like related to the exploration in 2011 of the Jedi robot, where they were able to use a snake-like camera and look at the back of the Gampton Brink so-called door.
Yes.
And based on what that robot found and published, I actually created a replica of the door, an exact scale model of it, with the copper electrodes, as I call them, and actually demonstrated how it worked on the Ancient Aliens show.
Oh, okay.
So yeah, it was like I was like the mad scientist in his lab, using muriatic acid and the zinc chloride solution and creating hydrogen, and then trying to blow up the lab with a long stick lighter.
Well, that must have been fun to do on TV. Yeah.
I know, yeah. And I know how television is, and I know they would have dearly loved to see my eyebrows singed in that shot, but everything worked out okay. But yeah, but then that actually the way that was designed was kind of interesting, because it shows that particularly in the southern shaft, where I proposed that a dilute solution of hydrochloric acid was used. The hydrochloric acid solution would erode certain elements, particularly the copper fittings and also the limestone. And the erosion pattern on the copper fittings would be reflects the function of that particular fluid switch, as I call it, so that you have the chemical solution that it's rising and falling, and the lower parts are affected longer than the upper part of it, so you have kind of a tapered erosion pattern on the pins.
Yes.
So that's one point to point out. And knowing that, then there would have to be some way of replacing them. And here we come back to that the whole question of internal ramps, and are there internal ramps, and if they are, where do they go? There are some researchers that claim that yes, there are internal ramps, and I think that there are too. And so when we're just discussing the existence of a grapnel hook and a stone ball, and we jokingly mentioned, well, I would have to have been inserted from the upper end, and maybe it was.
Right.
That's the other question. If indeed they had a passageway for maintenance workers to go up there to replace those copper fittings, which they would have to do because they were being eroded, what other work were they doing at the time?
Right.
And but even the red, they call it red ochre, but the markings on the floor behind the door resemble electrical symbols, and also seem to indicate the polarity of the switches. So that's all that evidence is, I think, fairly strong to say there must be some way for maintenance workers to make their way up to the location of where that Ganton Briggs door is.
Yeah, and when we were going through your book, you talked about, was it in '96 or something? Somebody was digging and hiding it. Did you ever find out any further information about that? Like it was after Gannon Brink had found the doors, and people were finding bags of chipped stone.
Right. There was a huge conspiracy theory going around the internet, and there was a few players on the ground at Giza who were feeding into it. Larry Hunter was one.
Okay.
Was I think the principal one. And some others, but they claimed that Hawass was actually digging in the Great Pyramid, and he had a tunnel leading from his bathroom up to the pyramids, and he was secretly going in there, chipping away limestone. But there was a presence of burlap bags in the upper chambers.
Yeah.
Danley actually pointed that out.
Right.
Where there were burlap bags, and then of course Larry Hunter comes in and he's feeling the cable. There is electrical cable going up into the upper so-called relieving chambers, and so he's assuming that they're using power equipment, and so that's where the rumor was nurtured and broadcast to become a conspiracy that Hawass was digging to reach the Ganton Brink's door. And then, of course, when they had the exploration in 2002, when they first did the drilling, they sent in an endoscope, which had a limited capabilities in terms of being able to look back and see what I'll look up or look down. It just looked straightforward and illuminated this. Looked like a plastered block where the plaster dried too quickly and there were cracks in it. And so I said, see, that's how I see he's patching up his work.
He's blocked the passage. Yeah,
not very well. But back then there was all kinds of excitement and scuttlebutt on the internet.
But
no
one's figured it out. Like,
they claimed that the official explanation was that the pyramid was closed for cleaning. It was closed for about 4 months. This was around 2000, the year 2000, something like that. And I was able to visit, the Great Pyramid in 2001, and went through, and it's like, they cleaned a lot. They, particularly the Grand Gallery was revealing, because that's where it revealed the scorch marks on the ceiling, that seemed to correspond with what the position of the resonators would be. So, they did a lot of cleaning on the inside.
Okay.
Did they clean out them slots?
No, I'd already done that.
You had already done that. Yeah, we're trying to start another, storm the Grand Gallery.
Yeah.
Movement, to get everybody to borrow a soup spoon from the hotel and storm the Grand Gallery. They can't arrest us all.
They can't arrest us all.
We'll excavate all those slots, and then we can finally measure every single one.
Yeah, Kyle's upset that none of the Pyramidiot guys, Piazzi Smith or any of them, went in there and did a bunch of minute measurements on the slots. What's the deal? They spent all that time in the antechamber measuring all the, all those little features, and they didn't measure the slots? What's the deal,
guys? They didn't have a soup spoon.
One curious thing falling into this, on our last visit, I took a magnetic field indicator and went all around with it in my hand. And when I got into the King's chamber, there's a metal plate in the floor.
Whoa.
That is, it looks like granite. It's been coated to where it looks like the granite, but it's a metal plate. Feels like granite, but it's metal.
That is the first I've heard of that.
I have no idea where that goes. And I asked people there that should know, and they said, "What are you talking about?" And took it and showed it. And I've been here for years and I've never seen that.
Wow.
So
how big are we talking?
Probably big enough to get a man through it, for sure. 36 inches square.
Holy crap.
It may have been more of a rectangle. I didn't spend a lot of time on it, but plate in the floor to cover something. I mean, if you want to seal an entrance and you don't have anything, the only way you're going to get in there with something to seal it without a lot of effort is to bring in a plate, put it in that location.
That's really interesting. That is strange. Is it where is it located is it near one of the walls or is it in the center?
It would be, that would be north. I lose orientation. It's on the north side of the coffer, the narrow end.
Oh, okay.
Of the coffer.
Wow.
Right in the floor.
That's crazy. Yep, we got to get one of those tools.
I was like, whoa, I actually found something.
Yeah.
You go back and look at old pictures that were taken, any time before the 1980s, there was a hole there. And that hole was still there when I was, back in the early 90s when I was there a couple times. That hole was still, they had just an iron grate over it. It's just a cosmetic cleanup, but that hole's well known. It's been there for a long time.
I was there when I was in there in 1986.
So is it just they pulled a floor block out or something, and is that what it was for?
So you propose it's to stop twisting ankles?
Probably.
Yeah.
So it wasn't a tunnel; it was just a hole.
You know, feed the conspiracy theories about.
Yeah, come on, guys.
That's right.
I want conspiracies here. We're not here for facts.
Okay,
I didn't see any hinges, that's for sure.
Yeah. But
So where do we go now? I think Robert's got some exciting information. You know, a lot of the new information that has been broadcast and is publicly known is all very exciting. But there's other research that has been continuing since 1987 that is equally exciting, and Robert has been engaged with a NASA engineer, and I'm not sure how much he can talk about it. Well, it's public knowledge. It's out on the internet, right?
Very little.
Very little of it, but hey, Robert, do you want to
take the floor.
discuss that? You know, before we do that, you know, as you had mentioned while you were going through my book, that I had contacted Robert back in 1997 when I was preparing my manuscript for publication, just to check on a few things, and we talked about acoustics, and he was recommended to me to talk to because he had a lot of experience with acoustics. He also had experience with Egypt, and like me, is a bit of a nerd. So anyway, so it was a really fruitful conversation we had back then. I met him after that at a conference, and we hit it off really well. But in 2016, as I pondered on, I've been asked, when are you going to update your book? You know, you need to write another book. When are you going to update it? And as I thought about that question, I thought about what some of the weaknesses were, and I came to the conclusion that the acoustic aspects of the Giza power plant needed to be fleshed out a little more. Mm-hmm. And so I reached out again to Robert, and the rest is history. But it was a very exciting period of time that we spent together in Egypt, and also in his studio, him coming over to Danville, all things pyramidical. Pyramidiate. So anyway, but and then he started to dig into some other research, which is absolutely blowing my mind, and has enormous significance in the function of the Great Pyramid. So, hey, Robert, take it away, man.
Okay. I think maybe the easiest place to start on this one would be an observation that Chris made in the book, where he said that the pyramid is acoustically coupled to the Earth. Mm-hmm. You guys picked that part up, right?
Yes, yes.
Yep.
Hello?
Can you hear us?
Well, I did. I don't know about the other three.
Yep,
Okay.
we got it.
You put them to sleep with your last diatribe.
No, we're here. You guys can hear us, right?
Okay.
Yeah.
So this idea that it's acoustically coupled, let's break this into a couple of pieces. One piece is to look at the chambers and the corridors as a tuned resonant chamber, as a system, as a complex system. If you look at the work of Danley, he looked at the King's Chamber, made some speculations about the upper chambers, but doesn't really go into detail about anything else. There's been a few other people that have taken a look at this little piece or that little piece, and they make a big show about it. The thought occurs to me that what we need to do is look at this thing as a system. If Chris is right, it's systems thinking. One of the ways I approached that was to look at, say, let's take the ascending corridor for a minute. Is that a corridor, or is that a 120-foot long, more or less, organ pipe?
Mm-hmm. Okay.
Is that an analogy that we can use? And
Right.
if you start looking at it that way, you can calculate what the expected resonant frequency is from its dimensions.
Yep.
Now, there's a lot that goes into that. End tone correction, it's a square pipe versus a round pipe. It's closed on one end because of the blocks, so that changes your harmonic structures, yada, yada, yada. That seems to be a little more detailed than we need to go into. But when you run the numbers on that, you find out that thing's resonating at infrasonic frequencies.
Huh.
Okay.
Okay, it's a couple octaves below what we can hear, probably somewhere down around 5.2, 5.5 hertz.
Okay.
Go ahead.
No, we're listening. Can you guys hear us okay?
You're
Sure.
cutting in and out on my end.
Okay.
I can hear you.
Okay.
But fascinating. Keep going.
Keep going. We're listening. It's great.
Okay.
The infrasonic's important, the 5 hertz. Keep going, Robert.
Okay.
Okay. So, and then as you look at other parts of the pyramid, when you're looking at it from the acoustics point of view, one of the first things you want to look at is parallel wall surfaces. I noticed you two guys play musical instruments. Do you gig?
Yes, sir.
We do.
Okay, so you've ran into something called feedback.
Yes.
Yes.
We don't like parallel wall surfaces.
Right.
Yes. Yeah, so this makes complete sense then.
Yeah.
Parallel wall surfaces and resonant frequencies that come out of that. So in acoustics, one of the first things you want to do is you want to identify those.
Mm-hmm.
And there's various ways to do it. And if you look at just the dimensions of, say, the King's Chamber, for example, roughly 17.2 by 34.4, that's an octave. Twice the distance is an octave lower.
Yes.
Okay. Yeah.
So they're emphasizing a certain frequency there. And it turns out that the height is also related to that. If you do a little bit of crunching on the numbers, you find out that that's related to a Pythagorean triangle, and that it's half the distance of the diagonal of the floor.
Wow.
To within probably a couple tenths of an inch. So what I see is that they're working with trying to emphasize certain frequencies and remove others, depending on which part of the pyramid that we're looking at. In other words, they're trying to create a very specific acoustic environment.
Yeah. A chord.
Yeah, exactly.
Can you explain your pressure wave diagram?
Okay.
It's hard.
All right.
If you guys have
If
graphics,
we look at it from a pressure wave point of view, let's go to the Grand Gallery for a second and pick up on Chris's resonator idea.
okay.
The only parallel wall surfaces in the Grand Gallery are side to side in the corbels that lead up to the roof.
Mm-hmm.
So the thought occurred to me that let's calculate out, because the measurements are only partially known, or at least partially published. Let's put it that way, on what those frequencies are, and it seemed to me that would give us an idea of what frequencies Chris's resonators would be working at. It turns out that there's 7 of those levels, and they're all tuned to within an octave. So it's 7 notes within an octave.
That's okay.
Yeah.
Okay, because the channel in the bottom and the roof are the same dimensions. And the width from wall to wall is twice that. So we're dealing with an octave here. So once again, a very specific audio environment is being created in there. So the pressure then builds up in certain parts of the pyramid as these resonance waves go. If you have your nodes and antinodes, and as you get those different frequencies building, the pressures can be quite impressive in a big hurry in a resonant structure.
Right.
If you guys have ever stood in front of a Marshall stack, you know what I'm talking about.
Yeah.
So you're kind of talking about the idea of standing waveforms in these areas, and the pressure side of the wave is basically like once you amplify it to a certain extent, you can get that pressure side way up there.
Way up there.
Right.
Obviously, and then your rarefaction on the other side would be equally, strong.
Yeah. So Eric, you wanted to chime in?
Well, I want to emphasize it. It was something that was just, oh my God, this is so amazing. The pressure waves in the King's Chamber specifically align with each line of blocks as they're stacked all the way to the top.
Wow.
Like the pressure waves are specifically falling on those stones to resonate them.
So wait a second. The nodal lines, like where are following the joints.
Yeah, the pressure point. If I'm saying it right, the waves that are created, the standing waves,
right,
line up exactly with the way the stones are stacked.
With the courses
That's
of blocks.
amazing.
So that all of those stones are by the sound that's being created.
Wow.
That's freaking awesome.
Another
How do you
thing I
build
didn't
like
know.
that? How do you build something like that? How would you know to build it that way? You'd have to.
My point is they knew what they were doing, and we're in maybe first or second grade trying to back engineer it.
Yeah.
Right.
That's what it seems like.
Yeah. So wouldn't you? I mean, this
Good way to put it.
this goes back again to the idea of like modeling in a computer in a program where you can actually run these models and say, well, where would the nodal lines be? Okay, this is where the joints in the stone need to be. Therefore,
Right. Well, that's what I did. That's what I did, and that's what I showed Eric. Those modeling programs are accessible. I have one, and I ran the modeling program. It's a lot more complicated than I want to try and go in here. Okay. People want to try and reduce everything to one number, and it defies that.
yeah,
Okay. The pyramid's much more complex than one number.
I'm just
Okay.
yeah.
It's many sciences coming together. I mean, you can pick an area, and that's whole different science.
Yeah.
Right.
Yeah. Which is a great segue for me. Thank you, Eric. Because that brings us to part two. Once we have this resonating complex of chambers and corridors up in the upper part of the pyramid, that brings us to the coupled to the earth observation that Chris was talking about. And this is where some of the really current work that I'm working on right now and that Chris is saying is opening up some interesting ideas. I noticed you guys seem to be aware of the piezo theories of let's vibrate things and the piezo will sit there and generate an electric field, right?
That's right. Yes, sir.
Yep.
Yep. Okay. Well, it turns out that we had a geologist with us on a tour a couple of years ago that looked at me and said, there's not enough piezo in there to really make much of a difference. And in order for it to really generate a field, it needs all the acoustic waves would have to hit it on axis. And the fact that it's natural granite means that all of the axis is essentially random. And you're not really going to get any significant currents or anything because there just isn't enough of it up there. Well, I go, okay, well, thanks for shooting my theory to little pieces. And that led me off into an idea of, well, is there some other mechanism that's at work here that maybe we don't know about? And that ran me into the work of a Dr. Friedemann Freund, who was out at NASA working with the Geocosmo and was studying granite and other igneous rocks. And he discovered that if you crunch them, i.e. put them in a hydraulic press, and start pushing on them, that they generate a current. And this is what's the theory of what's underneath earthquake lights.
Mm-hmm.
Okay. Yeah.
Yeah, ball lightning and such.
Yeah.
Yeah, ball lightning, earthquake lights, and all of that. So fast forwarding a little bit, I've been working with him and talking with him now for a little over a year. And so we're looking at this mechanism of vibrating the rocks and having it breaks the bonds that are down inside at the quantum energy levels in very specific. It only pretty much works in igneous rocks. That's where it works best. And without getting too technical about it, how much do we have to make them move in order to break those bonds? It turns out it's angstroms. And
Yeah.
Barely moving.
Yeah. So very,
and then the second question is how much force do we have to apply to those, approximately 60-ton pieces of granite that are up there in the upper chambers? How much force do we need to do that? It turns out a foot stomp or a hand hit is plenty, according to laboratory analysis on granites and gabbros and things like that since the 1980s that NASA's been doing.
Remember earlier I said, hold on, remember this, infrasonics and 5 hertz,
Right.
how that plays
So
in.
that's the hand, the foot stomp, the 5 hertz.
It turns out that in the earthquake's light, in the frequency that they're finding that is triggering the electrical effect in the rock, and we're not talking just about the King's Chamber rock, but every stone in the pyramid is adding to it. It's happening around 5 hertz. That's the peak electricity.
oh, okay.
I can't resist saying this, but I've got to. If you hit it too hard, it will really hurt.
5 hertz.
It'll hurt.
It'll hurt a lot more than 5.
A lot more than 5 if you hit.
Well, it could be that we're the same. Another expression of this same idea is the so-called ringing or fallen obelisk at Karnak,
Yes.
where there's a piece of one of the obelisks that fell over, and it's 5-6 foot square, maybe about a little over 20 feet long, and it's sitting on its side. And if you go on a tour to Egypt, one of the very common things to do is for your tour guide to get everybody gathered around this piece of granite that's about half the size of a school bus, if you were to chop it, horizontally. And if you hit the end of that with your fist, other than your knuckles going crunch, would you expect and saying ouch, would you expect to hear any other sound?
Not
No.
normally, but I have seen videos of them ringing that thing, so I know what you're talking about. Yeah.
That's it. It rings like a bell.
Yes.
When I told that to the NASA guys, they looked at me and said, well, of course. That's the only place I've ever found anybody that doesn't go to New Age woo-woo or some all sorts of other explanations. And the only place I have found a physical explanation for why that's happening. And all of this ties into Chris's ideas that if we look at the geology that's underneath Giza, it fits the model of these earthquake lights guys that are working out there at the NASA Geocosmo units and other places. It ties in exactly with what they're doing. There's basalt dikes, which are intrusions of magma that have solidified and become a basalt shaft. You get the seismic energy underneath going, and there's earthquake faults all over that area. And as it vibrates, then it creates these charges. These charges hit this basalt, go shooting up to the high point. They're searching for the high point of the local topography, and then it releases the energy. And
in the earth directly under the pyramid are these dikes. They're like electrical conductors, provided by the earth right up underneath.
Wow.
Yeah, and
That would pull the energy up. Yeah.
Yeah, it's one of the largest dike systems on the planet. It's called the Cairo mega system. It goes from east of Cairo, almost halfway to the Red Sea, all the way out to the Bahariya Oasis. It's one of the largest basalt systems on the planet. And Giza's built right at the top of it. There's like 5 points in the model, and Giza's a poster child all the way down the line.
Wow.
So the quote unquote primordial mound that is underneath the pyramid could be even the precipice of that, right?
It's perfect.
That's
Yeah,
very
it fits
interesting.
the model. It fits the model.
That's amazing.
That is.
I'm going to have to pull that up on my book of geologic terms.
Look at Bosworth's paper on the Cairo mega systems back in 2004.
Okay.
That'll be your best source. That's available on the internet. The so it turns out, and I really hate to say this in public, but maybe Chris was right.
I think he's very right.
I love to hear you say that.
So, but again, this is, I mean,
And there's more.
yeah. Oh, okay. Well,
Yeah.
just tell me more.
Keep
I'll
your mouth
stop.
shut.
I'll
Yeah,
stop
yeah.
talking.
Can I jump in, Robert?
Go for it.
So, in spending some time with Robert and learning the what he had discovered as the resonant frequencies of the chambers and their relative volume, I came back from the trip thinking, wow, my mind's blown already, and what am I going to do with this? And I come back to Rolls Royce and I show it to some senior level guys in thermal management. Their jaw drops open and say, "What are you doing next week?" "What do you mean?" "You need to go to Purdue University." Like the next week, I get back, I sit down and I watch a presentation on thermoacoustic engines, and I'm about to fall out of my chair because all the frequencies line up, especially the 5 hertz.
Wow.
And that focus of the 5 hertz, I think the most important part of the pyramid is the antechamber. It's focused at that location. And in a thermoacoustic engine, like I said, you have the relative volumes. The King's chamber is the hot section. The Grand Gallery is the cooling section. So you have hot and cold on either side of the antechamber. And as we look at what we do know, at least about the antechamber, it has vertical slots.
Mm-hmm.
And a thermoacoustic engine uses plates in what they call a stack, but it's not literally stacked. It's vertical, actually. They're more like side louvers. In this location of the antechamber, the frequency is right, the relative size is right, and the orientation of the slots is right for plates. I think they would have been copper or some type of metal that got taken out of there because it was precious.
Right.
And those plates would have caused your thermoacoustic effect. You get the proper temperatures on either side, and you get a phase change from liquid gas, liquid gas, liquid gas.
Mm-hmm.
And that happens when the temperatures are just right and the pressures are just right. It happens at 5 hertz.
Wow. Can you give us like a brief sort of overview description of what you're talking, a thermal acoustic engine?
Yeah. So you have let's build it as a stack that's completely vertical. You have a small chamber at the top that you need it to get hot, relatively small compared to a large chamber, which is tuned underneath where your stack is in between. So you have a hot chamber, relatively small, the stack. I'm going from top to bottom. Hot chamber, the stack, and then the resonant chamber. It's a cold section. Then below that, often we have a longer tube, and at the end, some type of an adjustment to set the tuning, which could also explain the granite plugs.
Mm-hmm.
Okay.
And at the location in this stack where you want to put an accumulator to control the pressure in the large resonator, which would be the Grand Gallery, the Queen's chamber is in the perfect spot, and it's got the right distance of chamber to connect and maintain a resonance in the Grand Gallery. And usually we also provide the working gas at the location of the Queen's chamber, which we'd call an accumulator. So if I run through the names that we've got, the King's chamber is a hot section. The antechamber is the stack, what you'd call it. The Grand Gallery is the main resonator and cooling chamber. The sending passage and with the granite plugs is the acoustic adjustment to tune the machine. Queen's chamber is a accumulator where you want to input your gas, and the horizontal passage is tuned to make sure the whole system can react. And a curious thing, I was explained the machine. I have an example of a machine that exactly fits what we've got here. And the student, it was a graduate student, had no idea what this was. She explained everything. I said, "Is that it?" And she said, "Oh, I forgot one thing. To get this system going, I have to hit it on the bottom with a hammer," which the subterranean chamber is explained by John Cadman as being a hammering device.
I have seen that, yeah.
Yeah.
Like the idea of water.
And when we had
a ram
when we
jet,
had our
basically.
geologist
Yeah.
there, I was a little stunned. He said, I see how it could work as a water hammer, but I don't see a lot of erosion like it was used continuously." And I had left puzzled with that. So I asked her, "How many times you got to hit it to get it running?" "Oh, just once."
Just one time.
Just once.
That's right.
So the subchamber didn't have to continuously run. It just got the system up and going and took off.
Wow.
I think this opens up a good place here. One of the things that Chris has been adamant about since I've known him is the need for an interdisciplinary approach. That there's no way that one person in one discipline can look at this thing and say, "I figured it out."
Right.
Anybody that's done that, their mental capabilities are way beyond mine, and I can't even picture it. I agree with Chris on this point. So he's working on trying to put together a team that has, or a network that has all sorts of specialties that we can bring to bear on this thing and says, "Does this make sense from your point of view? Or does this, or some other point of view," like the geologist that looked at me and said, "Well, your piezo theories are interesting, but it won't work." Okay. So then I had to go find another idea. And I think he's really right about that. And I think that's one of the strengths of his work, if I can stroke him a little bit here, that, yeah, that seems to be what we're trying to do, and maybe we're getting someplace.
I think so.
Yeah, there's several people. We could go through a list that help us. Everybody's got a piece of the puzzle. The Thermoacoustic, I need to mention Danny Kerr, Tesla Pyramids website. He's helped in discovery and supporting that it's thermoacoustic engine.
Well, if you guys need podcasters on your team,
and then
just
as far
let us
as
know.
the entire plateau in resonance, it's funny, Doug Keenan, he only lives 15 minutes from me. You know, why?
The plateau itself?
Yeah, Doug, and he's got a website, Big Star Map.
Big sky map, isn't it?
Big Sky Map, yeah, I'm sorry. And he's looking at the distances, if we're talking about sympathetic resonance to the Earth in the dimension of the Great Pyramid. That was mentioned, I think, your episode 3 or so. You were looking at the book, and Chris notes that the physical dimension matches a fraction of the Earth, which means it's in sympathetic resonance to the Earth.
Yes.
Right.
Yeah.
It's
if you then look at all the sites, the distance of other pyramids in the Giza area from the Great Pyramid, if you think of the Great Pyramid as the signal generator, their relative distances, Doug Keenan has found out that the relative distance and their relative size responds sympathetically also to the Great Pyramid.
Wow. So let me get, so you get the Great Pyramid going, and then you can build at these other sites and draw off of that, or just get those pyramids going as well? Like, are they each one a generator or focus?
As Robert has explained, because of their shape, because of the stone within, the proxy bonds, earthquake lights, they're going to be generating a higher voltage at the point.
Okay.
How they played in, we haven't had time to study yet.
Got it.
Yeah.
See, I had imagined that too. That if you look at the surface of the planet, like a Chladni plate, for example, like cymatic resonance.
Right. Yeah.
Then
Exactly.
you could follow these nodal lines and say build your pyramid in the middle of this resonant area.
Yeah.
As opposed to on a nodal line.
Yeah, a couple of comments on that. One is that as you're looking at the geography, let's look at the definition of a sacred place for a second. Maybe the place is sacred because there are energies that are building up there. They knew it, and therefore the building was built there. It isn't sacred because the building is there. Mm-hmm. That's why they put the building there.
Yes.
Does that make sense?
Yep. Absolutely.
Yeah, so they knew about the energy buildups and this and that. On a relatively side note, on a more speculative but interesting one, you guys are familiar with Richard Hoagland's work on circumscribed tetrahedral geometry?
I'm familiar with Hoagland. I don't remember that specific work, so give us a short rundown there.
He noticed that the great red spot on Jupiter is at a very specific location. It's 19.5 degrees north latitude. And as he looked across the planets, and including Earth, he noticed that 19.5 kept showing up in various places. On Earth, it would be Mauna Kea, where you have a constant upwelling of energy, and as the plates go across it, you have the Hawaiian Island string.
Okay.
You also see that on Mars, Olympic Mons, and this and that. And he was writing about this back in the early 1990s was when he was doing most of his work on this. If you project that onto a sphere, you come up with a certain geometry, and that's his circumscribed tetrahedral geometry. One of the ways to work with that's interesting is to say that if we're vibrating and resonating within a sphere, then you would expect harmonics to build. And from an acoustics point of view, anytime you're looking for harmonics, one of the first places to look is where's the dominant fifth. That seems to carry a lot of energy.
Right.
Well, it turns out if you do the math on that would be slightly under 20, 29, 30 degrees, right, just under 30. 29.25 would be your mathematical most likely place to look. And Giza's just under 30 degrees.
Oh, yeah, that is true.
And if you look at the sun, you have the butterfly charts where your sunspot activities starts just under 30 degrees, and then they get closer and closer to the equator, and then the sun flips poles and it starts over again, just under 30 degrees. It would seem that maybe Hoagland's assertion is that maybe this is trying to tell us something about physics that we don't understand yet. But if he's right, Giza falls into that pattern as well.
Okay, so it's put into the right place for that pattern as well. Ah, that makes sense. Wow.
I love it. Tell us more.
Keep going.
And there's more.
Oh, one other thing I'd like to add that Chris was, as we're looking at, is not only just the seismic energy of all of the earthquake faults and everything running around. Another major contributor is probably ocean waves, which are just continuously lapping up against land masses and creating these vibrations that bounce all over the earth.
And they all pass through that point.
And this seems to be tuned to resonate with those frequencies and pick it up.
Wow, and that comes back to the moon as well. It's like Chris said in the book, as long as the moon is orbiting the Earth, all of these resonations will continue to happen. So it's like a free lunch, basically.
That's it. With the one point to maybe drive home, we're not talking a Tesla electromagnetic resonance here.
It's mechanical.
Okay, we're talking
Acoustical.
acoustic resonance.
Okay, yeah.
Yep. That's my thing. I love that.
Yeah, that's Kyle's deal.
I'm into that.
Good at getting feedback, huh?
Yes. I'm into turning Ty's feedback down.
Yeah.
But,
the lead guitarist. Yeah.
That reminded me, there's one other little thing that I'm finding in the King's Chamber specifically. And that is that some of the dimensions and some of the resonant frequencies that I've measured in there appear to be beat frequencies.
Ah.
You guys are familiar with beat frequencies?
Yeah, harmonic beat frequencies, yeah.
Yes, harmonic tuning on your guitar, exactly. So to the people that don't know this, I think the easiest way to explain this is that if you take two notes sufficiently far apart from each other, they form a chord. If you get closer and closer and closer with those frequencies, all of a sudden it starts to beat. It almost sounds like a thumping drum.
Yeah.
You only have, and so it's actually hammering. It's creating a pressure wave that's beating. There's beat frequencies in there too.
Yeah.
That helps us get to the infrasonics.
Yeah. So are the beat frequencies are audible?
They're infrasonic.
Okay.
Okay. But I mean,
They're down around that 4.5, 5 hertz
okay.
range also.
And these are going to
You
help.
can feel it.
These are going to help generate the. These are going to help the piezoelectrics go generate the microwave frequencies. Is that the idea?
No, it's
No.
not the piezo.
Okay.
There isn't. I don't think there's enough of it in there to be significant the
Okay.
way that most people want to drive it.
All right.
Well,
What's
If you-
underneath this is the actual chemical construction within the igneous rock, specifically the Aswan granite itself.
I do believe, though, Robert, it helps get it started, because if you analyze the amount of ionization needed for hydrogen to make it electrically conductive, it's only 1%.
Okay.
So the
Yeah.
amount, even the tiny amount of, it's not tiny, it's significant enough. The amount of piezo that's in the stones of the chamber are enough to excite the hydrogen to plasma state.
Wow.
Yeah.
1% ionization. And then you, I mean, it's not like it's going to stay there. Then you get a ramp up of everything at once. It's like a starting circuit.
Yeah. So when we look at the Freund effect, for the lack of anything else to call it, that ionization, the ionization that occurs on the surface of the granite is enough to ionize air. So we're looking at tens of thousands of volts, if not more, that's being generated by the bonds breaking within the granite itself on certain chemical bonds. I don't want to try and get too technical here, but it also creates a situation to where they start reinforcing each other, and it's a good way to get massive amounts of energy if you have, say, a chamber tuned to an octave of itself, where you have, like the King's chamber, where you have one side that's 1 octave and then you have another octave there. You get slightly less than double the amplitude for free, just in the way the sound's bouncing around the room. So you don't have to build the pyramid's big enough, but you don't have to build huge chambers to get resonant structures that are down in these sub-audible frequencies. You can use resonance itself and beat frequencies to create those. And that seems to be what's going on.
Okay, I think I see what you're talking about.
And one thing that's clever, if it is hydrogen in there, ionized hydrogen is a superconductor for electricity.
Ah.
So that could put the northern and southern shafts serving dual purpose. They're waveguides, as well as once the hydrogen would ionize in those shafts, they're also sort of forming the shortest path from the King's chamber to the surface as large conductors.
Awesome.
So what would be the distribution system? I know this is more speculative, but if they were generating energy in here, how are they distributing it?
Well, we think as wires, because it's how we've grown up. But
Right.
if it's transmitting to the ionosphere, you just need the shafts or the obelisks.
Okay.
And it brings it down.
Yeah, there was a very interesting art installation that was done in Bristol, England years ago. I don't remember the artist's name. But he took just a bunch of standard fluorescent tubes that you'd have in a workshop lamp. Just the long fluorescent tubes.
Yeah.
And he just stuck one end in the ground, but he did it underneath these high tension power lines. And that was enough residual energy that it lit those fluorescent tubes up. You didn't need anything else. You didn't need wires. You didn't need Tesla. You didn't need any of that. Just stick one end of the tubes in the ground.
Huh. Well, yeah, I know the Earth is a huge electron sink, so that does work.
Yep, I had an old, Archer gave me an old neon sign transformer, and I have this. Trying to remember what it's ultraviolet light bulb that was supposedly burn out, and I didn't even connect it to this neon sign thing. I just plugged the transformer in, and the light bulb in my hand lit up. I was like, okay, this light bulb still works.
There you go. It's a big neon transformer. That's a good explanation.
Yes,
Darth Vader.
that's right. I had a lightsaber.
I am your father. And now you're dead.
Oh man, well this has been great, guys. You guys have more? You want to keep going?
Well, I think we should kind of wrap it up for now. Is there anything else that you guys want? Does Archer want to weigh in and introduce anything?
I've just been along for the ride here so far. So far, you've answered most of my questions.
Yeah, I was going to say.
All right. So
I'm about to ask a question, and then it gets answered.
Yeah, I'm really glad to hear, Chris, that you're continuing your research on this, and that you're building this team, and that's the most exciting news I've heard all year.
That's right.
That you guys are
It's a brand new year, so.
Well, I set out to find people. I set out to find people that were smarter than me, and
He's still looking.
Eventually, you will.
No, seriously. You have to, right? But I succeeded. These guys are top notch.
They are. Well,
right?
we were saying if you guys need podcasters on your team, just let us know.
Yeah,
we'll join up.
Hey, you want to go to Egypt, right?
Yes.
Oh yeah.
yes.
Well, I've got a tour coming up in September, so maybe you should go on that one.
Oh man, we're already going to be in the Scablands in Washington during September,
well,
but
good luck with that.
Maybe the next one.
Okay. Are you going to be a witness at the impeachment trial? Or?
I can't talk about that.
Wrong Washington.
Yeah, no, Washington State.
Sorry about that.
Different Scablands.
Yeah.
Yeah.
Oh man, you guys fit into this podcast perfectly, I have to say. And yeah, Robert, I wanted to say, Robert, you're the second front of house engineer we've had on here. You guys seem to be really interested in this stuff. We had Scotty Baldwin come on the show. He was Prince's front of house guy for a long time. So it was yeah, great. It's been awesome talking to both of you. So I just want to give Scotty a shout out. You said front of house. I was like, hey, seems to be a trend here. You guys seem to know what's going on. So.
Well, it's one way to get a practical understanding of what does sound do in big places.
Yes, absolutely.
Yeah.
Yep.
Could I mention my website before we close out?
Yes. So tell everybody how to get a hold of you and how to find your work for sure, please.
Yeah. www.gizapower.com. That's GIZAPOWER. And there you will find all things weird and wonderful, lots of photographs, information about past tours and upcoming tours, but no biographical information on Robert and Eric.
Yes, I discovered that.
The truth is, he just asked us to come along and carry his
Yeah.
power.
Yeah.
How
Bring
big?
spoons.
How big are your tours?
I think somebody did that. Eric, I put him in charge of carrying my tools,
Oh, I had to rent a horse.
and we went to the Serapeum. And I said, "Okay, Eric, where is my gauge?" And he said, "Oh, I forgot. I left it in the bus." And so he had to hop a camel to go back to the bus.
Fired.
I had rode the camel down to the Serapeum. I wasn't riding that camel again. It was too boring.
Yeah, the
I got
camel.
a really nice horse, and he was ready to run, and went and got the tool and came back.
Yeah, the camel was
And then
for
we
all the
could use
tools.
it, right?
Right.
Yeah.
That's another
Kinda
story.
That was another story.
Yeah.
Murphy's second law. Murphy was an optimist.
Yep.
Lots of fun. Lots of fun.
Well, this has been excellent, guys. Maybe we can have you back on sometime because this has been awesome, and I think there's more information. So
There's a lot. Yeah, there's a lot of information, and
Yeah.
I mean, you could have either one of us, Robert, Eric, me individually. Your
Yes.
choice. Well, Robert, I'll give Robert your email address. Robert and Eric your email address,
excellent.
and you can make contact that way. I will update my website with Robert and Eric's biographical information. So, actually, I do have a little bit of it there on the 2019 tour.
Oh,
right.
okay.
Yeah,
Yeah,
and the 18 tour.
yeah. So, what are you complaining about then?
I was looking in the about Chris section, and I didn't see anything on them.
Chris, you do have a section.
About Chris is about Chris.
Yeah. Hey, I was just.
There's a section in there where I redid some of Chris's work when I just started.
Oh yeah, the Petrie core number 7.
Yeah.
Oh,
Oh, okay.
Great. I'll have to look at
That's
that.
that's an updated one.
is it a
It's,
spiral?
Oh yeah,
It is.
It is.
I verified.
All right, cool.
totally. No argument. Okay, guys, it's been great. You guys are a lot of fun. I'm going to be tuning into your show from here on out. So.
Thank you.
See,
amazing.
I used to get props for doing Christopher Dunn impressions, and then when I found out you were listening to the show, I got scared. So I stopped doing. So
Now you know you don't have to fear anything, right?
okay, yeah. Now that we know each other, I'll continue making fun of you as I always have.
If I see you coming at me with a fluorescent tube, I'll run
You'll at
the
least
other
see
way.
him coming.
Yeah.
Yeah, an illuminating experience.
All right, guys.
All right.
Thank you so much.
Yep.
And wish all of you a good evening and a good weekend. Thank you so much. It's been a blast.
Yeah. Appreciate it.
See you later.
Thank you, guys.
Thank you.
All right, ladies and gentlemen, there you have it. Chris Dunn and et al.
Chris Dunn et al.
Breaking news.
Yes.
I mean,
lots of breaking news.
Yeah, amazing stuff they're working on. Man, we got a lot of stuff to look into now.
Yeah.
So I hope you all enjoyed that. We thoroughly enjoyed it and wanted to thank Chris and his friends again for coming on. Hope to have them back soon with more updates.
My only complaint is, Chris, you're not allowed to come on this show and be funnier than the hosts. But no, it was great. When we first connected with those guys, it was obvious that they belonged on this podcast because they were hilarious. So we had a lot of laughs before the show and after, too. So it's a lot of fun. And some mind-blowing material there. Like Kyle said, breaking news.
Oh, I'm about to bone up on my waveguide technology
Yeah.
studies
Yeah.
in order to really ask some good questions and
Yeah.
understand
Yeah.
what they're working on now.
Right.
Yeah.
And I think, and we talked about this a little bit, might get some of them on in the future separately and dive more deeply into their specific areas. Because they obviously have a lot more information that we weren't able to get through in this 2-hour show. So,
Yeah. Especially the acoustic resonance stuff. I mean, that
Yeah.
was just mind blowing.
Yeah.
Wow.
and I want to understand more about the quantum aspect of the Piezo effect that he was
Right.
talking about. And because I had some questions on that, but he kept saying, let's keep it at this particular level and not go too deeply into the science of it. But I want to know, I wanted to ask things like, okay, so if bonds are being broken, are they being reformed, or can we find signs of that in these stones if we do the right tests?
yeah.
Well, and I thought he said it wasn't exactly a Piezo response.
Yeah,
It
yeah,
was
but he was
something
talking about
different.
how
Like,
you're right. He was saying that there was not enough energy for that particular Piezo response, but he was saying that there was something happening at a deeper level.
right.
Yeah.
Yeah.
You might see me in the future smashing a granite rock with a backhoe and testing it with stuff. See what.
Does it ring?
I know, and I wanted to mention Ringing Rocks Park. Like,
Yeah.
I thought of that too, and he's, I'm thinking like we've been fascinated with lithophonics for
Yeah.
years. So, and that just even more strengthens my idea that some of those places are actually the remnants of ancient structures.
Oh, that was the thing. We forgot to ask them if they wanted to join our Pyramidians rock band. And
Oh,
I mean, it
dang
seems
it.
like they've actually already formed the band, and we might have to try to
We
join
might
their
have
band.
to join their band. Yeah, yeah,
We're just groupie status.
yeah, right, yeah. Well, I'll play the trumpet. So yeah,
Megalithica.
megalithic. Yeah, well, we already have a front of house engineer.
That's right.
I mean, we're good to go.
Well, technically, you got two.
Yeah, we got 2 front of house engineers. Like, this is serious here. I guess Scotty can run the monitors because he's really good at that, he says. All right, don't forget to check Chris's website. He gave it out, but I'm going to give it out again here. It's, let me make sure I got it right. It's GizaPowerPlant.com, I'm pretty sure.
Giza Power.
GizaPower.com, yeah. So here it is, GizaPower.com. So he is doing tours, and they're going to Egypt and looking at this stuff. So if you guys are interested in that, and we certainly are, go to his website, and you can get information about the tours and learn how to sign up. So I would definitely recommend that. And, of course, he's got a bunch of other material on here. Articles, all of his old articles and newer ones, activities, links. So check it out, GizaPower.com. And you can get a hold of us, Brothers of the Serpent, at gmail.com. We have a lot of emails in the hopper, and we will be getting to those in the next shows. Sorry we didn't do any of that this week, but this was all about the interview. Also, check our website, brothersoftheserpent.com. You can find the encyclopedia, the glossary there. The snake skins was our merchandise. You can check out you can join the pyramid scheme and send us straight to pyramids by donating to us through Patreon or PayPal. Also, all of our older shows are archived there on the website, or they're archived on YouTube. You can give us reviews on iTunes. That always helps. Share the shows anywhere you can. Follow us on Twitter at Snake Bros with no vowels, SNKBRS. Join the Facebook group, which is run by Jordan. You can join our Discord chat. There is a place on the website to find the Discord chat and a connect button there, so you can join up right there. It's real easy. Don't forget about the Library of the Serpent, run by Jeff. Jeff also is the de facto administrator of the Discord chat, so be real mean
Thanks,
to
buddy.
him. Yeah, get in there and troll him real hard. And don't forget about History Shift, who makes all of our YouTube videos. You can follow him on Twitter at History Shift, or find him on YouTube as well. And he has a website, historyshift.com. Also, follow Pod Doodles. He takes our podcasts and turns them into doodles, which you can watch while you listen to the show. It's fantastic. So you can follow him on Twitter or find him on YouTube. And also, don't forget about Cosmographia, which we do with Randall Carlson. You can find that at Geocosmic Rex or the Cosmographia channel. And I think is the CAC 2020 Scabland still got a few spots left if you want to go to Scablands with Randall.
Yep.
So sign up. Get a hold of Darren at grimerica.com. And I think that's it.
Yep.
Yep. Man.
Loving every minute of it.
Yeah.
Hey,
This was a great show.
Yeah.
I hope you guys enjoy it. Good night, Adamu.
Love
Get
you.
back to work. Always have.
Always well.
Always will.
Word.
Turn it up, Scotty.